we've been at this for about a month. It may seem like it's been years, it may seem like minutes ago that you first found out that you'd be working on these pieces of legislation. And one of the things I always ask people to do in the midterm briefing in the summer is to think a little bit about how much more you know about the topic that you're studying and the legislation than you did a month ago. And if you pause and think about that, that's a lot of what this process is about. It's learning by doing. It's taking the time, working in groups to really become expert about, at this point, the bill itself, the environmental problem, the science of the problem. By the end of the summer, you'll be expert at all. So without taking any more time at this point, our first project is has been working with Professor Absent. And if Nick is ready, come forward and do the research.
Hello, is it good? Hello? Is everyone here? This is cool. So, good morning, everyone. My name is Nick Venencia. I'll be presenting our midterm briefing for our workshop group. Our faculty advisor is Dr. Howard Absent, and our legislation is House Bill 610, the San Francisco Bay Restoration Act. I'd like to extend a quick thank you to my task team this week, Will and Hunter. Thank you guys so much for all the work you put in helping prepare for this, as well as a thank you to the vesting rights, my workshop team. Thank you guys so much for being the greatest workshop team, and also I look forward to the research we have to do. So just a quick rundown of how I'll go through this presentation. I'm going to start with our legislative summary, of course, talking about brief facts about the importance of the San Francisco Bay, and then I'll go into defining the environmental problem, as well as talking about the science of the environmental problem, as well as who the problems affect most. And then lastly, I'll talk about what's next to our research before answering any questions. So a quick legislative history. The Federal Pollution Control Act of 1948 was the first big federal government legislation to try and address pollution in water nationally. It wasn't really that effective. It wasn't until 1972 with the Clean Water Act amendment. There was actual structure to regulate pollutants within water. And then another significant part was added in 1987, the Clean Water State Revolving Fund. It was a loan service offered by the EPA to states to help them manage and clean up their waters. And all of these come together for the San Francisco Bay Restoration Act, which is an amendment that seeks to add a specific part of the Federal Water Pollution Control Act of 1948 that will address the problems within San Francisco Bay and the estuary. So the Bay Area, it's home to over 8 million people. Excuse me, not 8 million. Excuse me. Just go back. Some key provisions I want to go over of the San Francisco Bay Restoration Act include the establishment of a federal grant program to fund research projects and cleanup efforts within the Bay. It will also create a San Francisco Bay program within the EPA's Northwest Regional Pacific Office headquarters. In conjunction with the state of California and local governments, the office will work to manage, research, and conduct plans that will help clean up the Bay estuary with a focus on water quality improvement, endangered species recovery, and mitigation of climate change. All right, so back to the Bay Area. The Bay Area is home to over 8 million residents of it's a hub of diverse sectors such as shipping, tech, finance, and it's also the 12th largest metropolitan area in the US, with the 3rd largest urban economy. The map you're looking at here shows the 9 counties within the Bay Area. Within it, there's 100 cities and towns. And although rapid development has helped the area succeed, it's also led to the degradation of the environmental quality of the Bay. So just some quick ecological background. An estuary is a tidal mouth of a large river. It's usually where a river meets sea. So because of this, the water in estuaries is brackish, which means the salinity is in between salt water and fresh water. Because of this, estuaries have a perfect environment for a diverse range of species, that have adapted to live in brackish waters. San Francisco Bay particularly is home to species that can only be found there. The San Francisco Bay is a big body of water that encompasses other bodies of water. It actually has 4 bays within it: the Sassoon Bay, the North Bay, the Central Bay, and the South Bay, all of which have different environmental qualities. There are many rivers, salt ponds, wetlands, and waterways within the San Francisco Bay. Overall, it's a sediment-rich environment, home to endemic and endangered species. So the environmental problems, there are a bunch of environmental problems that the legislation seeks to address that affect the health of the bay. But before we focused on where it's habitat degradation, invasive species, pollution and runoff, and climate change. So the first one, environmental habitat degradation, environmental loss. Environmental alteration of the San Francisco Bay Area began with European colonialism in the 1700s. And after the 1800s, 95% of tidal marsh and wetlands were lost. As you can see on the map, the green is tidal marsh and wetlands, and as of 1998, most of it's lost. So when you lose this, you're not only losing a habitat to over 500 species, but you're also losing a climate regulator, as the tidal marsh and wetlands helped filter the contaminants that went to the bay, as well as help to regulate coastal temperatures. So the people and species most affected by this are the habitats, the native species that call the wetlands their habitat, and also due to the environmental degradation and the habitat change, fisheries in the bay have been reduced 5 to 10%. Another big problem is the diversion of fresh water from the estuary to supply the rest of California. This ends up with fragmentation of streams and rivers within the estuary, as well as it changes the salinity of the estuary as the fresh water is taken out, it becomes more salt. The next big problem we focused on was invasive species. One new invasive species was added to the bay every 14 weeks from 1961 to 1995. And currently 97% of the species within the bay are non-native. The thing about these invasive species is they have no natural predators, they disrupt food chains, and they often reproduce too much, taking resources from the native species. A big driver of this is ballast ship water. Ballast ship water is water that ships take in at their point of origin. And then once they get to their destination, they release this water. Inside can have microbes, invasive plant species, and invasive animal species. The next big environmental problem we focused on is pollution. There's a bunch of different pollution that affects the Bay Area. First of which we focused on the sewage pollution. A lot of the sewage treatment plants in the Bay Area were built in the 1950s and haven't been upgraded since. So they're very susceptible to overflow events when sea level rises, as well as when it rains a lot. These overflow events result in sewage overflow, so raw sewage can get into the bay, containing pathogens, bacteria, viruses that can affect humans and the organisms they come in contact with. This mainly affects low-lying communities in the Bay Area, which include low-income individuals and non-native U.S. citizens. There's also a problem with industrial discharge. There's 1,300 industrial facilities in the Bay Area, some of which their chemicals end up into the bay. These chemicals include mercury, copper, and lead, all of which can have adverse effects on the organisms that live in the water. For example, salmon, when they come into contact with copper, they lose their sense of smell. And without that, they find a hard time trying to spawn, as well as avoiding predators. Birds that also come into contact with lead can be very fatal. And the last pollutant when it comes to industrial pollutants is legacy pollutants, which pollutants from the past, whether they've been dumped into the bay a long time ago, or they're from facilities that are buried near the bay that seep into the bottom. Usually these legacy pollutants stay within the sediments on the bottom of the bay, but the constant influx of water in and out of the estuary causes these sediments to move, unearthing the chemicals on the bottom. Such industrial legacy pollutants like DDT, a synthetic agriculture chemical that was banned in 1972, they cause that one specifically causes paralysis and death in some organisms. There's also a problem with bottom feeders that unearth legacy pollutants, such as shrimp and small fish that eat on the bottom of the bay. And as these pollutants get into their bodies, it travels up the food chain as they're eaten by bigger organisms. So the last pollution we looked at was plastic pollution. Plastic pollution gets within the bay from sewage runoff, as well as rainwater runoff, and just plain old litter that ends up in the bay. So microplastics are broken down pieces of plastics. They're really hard to get out of the environment. And they're considered microplastics when they're broken down to less than 5 milliliters in width. They often contain PCBs, which can cause liver failure, cancer, and death within organisms. In a case study we looked at, to understand how the microplastic got into the food chain and then travels up to bigger organisms was a study of 2 prey fish within the bay, topsmelt and northern anchovy. They looked at 8 different locations all around the bay, 2 of which were outside urban areas to broaden the range of the research. And they found that 35% of the fish had plastics within their system, and on average, they had 0.6 to 4.5 plastic fibers in the bodies. So that's a picture of northern anchovy. You can see they'll eat microplastic, and then that's a picture of northern anchovy being eaten by a tern, which is a migratory bird that stops in San Francisco Bay at certain times of the year. So as they eat these fish, the plastic bioaccumulates more and more, and has significantly worse adverse effects as it moves up the food chain. So the last problem we looked at was climate change, which has already significantly started affecting the bay. Sea level rise makes that sewage treatment plant problem that I said a lot worse, because a lot of the treatment plants are located on the coast of the bay. Sea level rise also leads to salt water seeping into the freshwater sources within the estuary. Climate change leads to more powerful storms, which leads to a greater level of coastal erosion. This picture was taken from 2010 within the bay, and as you can see, within a month, a big chunk of the road is gone, coastal erosion. That divider that is circled in the first, by January 20th, the end of the month, that divider ends up at the end of the coast because of storms. So climate change will make storms that cause this more frequent and also a lot stronger. And climate change will also lead to increased temperature, which leads to more moisture deficits within the bay and also a lower snowpack. The snowpack melting is where the estuary gets its fresh water. So without that, there's less fresh water for the estuary environment and less fresh water for the human activities, such as agriculture and recreational activities that depend on it. So it directly affects the economy. And so with that, I'm at the end of our presentation. 2 weeks from now, John Luca will be giving a briefing on the proposed solutions to the environmental problems I outlined. With that, I can take questions.
Over there, can we get to a microphone?
I think that they're all off, but Nick can repeat the question and
Okay,
then.
they'll repeat the question. Go ahead.
As far as the 7 or 97% non-native species, is it still going to try to reduce those species or just prevent more non-native species from coming into?
So that's a great question. That's definitely something we'll address. Oh yeah, sorry. So the question was, will the bill try to address the non-native species? Actually, can you repeat it one more time?
Will the bill try to address the current 97% of non-native species that are in the bay, or is it more about preventing more non-native?
So is the bill more about preventing more non-native species from coming in, or reducing what's currently there? Yeah, that's a good question. That's definitely more of something we'll explore later in the research when we look into the proposed solutions to the problem. So I'll definitely circle back to you if you want to learn more about that.
Other questions? Okay.
I have a quick, maybe I just don't understand, how does sea level rise make the CSO runoff work?
Because a lot of the, like I said, the sewage treatment plants, they're on the coast. Oh, yeah, I'm so sorry, guys. So the question was, how does sea level rise make the sewage runoff worse, correct? Yeah, so because a lot of them are built on the coast, as sea level rise gets higher and higher, it's a lot easier for those to overflow and flood as the coast is closer.
Okay, time for one more. Here's another question. Seeing no other questions, thank you. Great. We're going to take a brief, not by 2-minute break, and then we'll resume.
I mean, like, well, for first, I think it is
Okay, so our second briefing. Okay, our second briefing is going to focus on the area of clean energy and the Sustainability Accelerator Act. This is the group that I have been advising, so they were operating under some severe constraints, given some sympathy. So if Julio is available, can you please come forward and give briefing?
Hear me? Okay. Good morning, everybody. I am Julia Saccardiana, and today I will present to you my team's work so far on the Clean Energy and Sustainability Accelerator Act, also known as HR 806. Before we begin, I want to thank my team managers, and Dr. Cohen for their support and help present and preparing for today. Now, without further ado, let's roll on into it. Now, today I'm going to be asking and answering a lot of questions, but all you need to know is that we will discuss what the Accelerator Act is, the environmental problem it addresses, and the science behind those problems, as well as next steps. So what exactly is the Clean Energy and Sustainability Accelerator Act? Well, before we go into that, let's look at the pre-existing conditions. There's already currently a market for investment in clean energy and sustainability projects. However, the transition to a sustainable economy must be faster. So, where does the Accelerator Act come to play? The Accelerator Act provides a plan to create a federal green bank that will support local, state, and regional green banks that already exist with additional funds and resources, create and establish local green banks that do not yet exist, maintain a relationship with private investors to assure efficient policies, and supply direct additional funding to sustainability projects. And all of this combined creates the Green Accelerator. So this Green Accelerator will inject $100 billion into the market for sustainability and clean energy efforts. And I also want to note before we continue that the Act explicitly states that 40% of this $100 billion will be directed towards climate impacted communities. More on that later. So what are the major goals of this act? Well, there are four, and they are to mobilize private capital through federal investment, benefit climate impacted communities that are disproportionately affected by the climate crisis, to support workers in communities impacted by the transition to a sustainable economy. Is my microphone okay? Okay, good. And last but not least, transition towards a clean energy economy without raising energy costs to end users. Now, let's go into the environmental problem that this act addresses. Why is this Accelerator Act necessary? Well, there are global temperature rises happening, and the 10 hottest years on record occurred all since 2005. And preliminary data from NASA shows that 2020 and 2016 are tied for the hottest year on record. So why does this matter? Why should we care about rising surface temperatures? Well, the impacts of rising surface temperatures include rising sea level rises. Specifically, NASA has data that the sea levels have risen about 3.4 inches since 1983. And also, these changes lead to an increase in permafrost loss, permafrost melting, which destabilizes global weather patterns and tundra environments, which also contribute to more extreme weather. And this extreme weather can include hurricanes, wildfires, and drought, which can also lead to desertification. And all of these climate changes combined contribute to biodiversity loss and even mass extinction. Therefore, there are clear and serious impacts of climate change. So what human activity contributes to this issue? The main contributor to rising surface temperatures are greenhouse gases emitted from human activity, like the ones you would expect, energy production and industrial processes, but also human activity like agriculture. And furthermore, the same activities that increase the greenhouse gases in our atmosphere also have byproducts of chemical waste that can lead to a variety of adverse health conditions. And when these pollutants go into an area at high levels, they can have catastrophic health effects. And speaking of highly contaminated areas, who suffers the most from these problems? There is a disproportionate environmental distress depending on where you live. But before I continue, I want to make clear that everybody is affected by the climate crisis. However, while the risks of climate change and pollution are harmful to everyone, communities of color and low-income communities are disproportionately affected by the climate crisis. Why? Well, the fossil fuel industry builds much of its physical infrastructure in low-income areas where residents are also often people of color. The environmental and health hazards created by these facilities carry far-reaching consequences for these communities. Compounding this issue, government agencies are far less responsive to low-income constituents. This is why the Accelerator Act explicitly states that 40% of that $100 billion stimulus will be allocated to these climate-impacted communities. Now let's dive a little deeper into this problem, into these problems, into the science behind them. So what causes rising surface temperatures? The answer, as we mentioned before, is greenhouse gases. Greenhouse gases can include water vapor, ozone, carbon dioxide, and nitrous oxide. And these gases play an important role in balancing the Earth's energy budget, meaning they convert energy from the sun into heat to maintain a livable environment for the planet. However, since human activity, the human activity we mentioned before, has led to an increase of these greenhouse gases in our atmosphere, the Earth is warming at an unnaturally high rate. And greenhouse gases like carbon dioxide and methane accumulate in the atmosphere, and their residency time, or how long they stay in the atmosphere, is high compared to the rate they accumulate. In other words, the rate at which carbon dioxide leaves the atmosphere through natural processes is outpaced by the rate it is input. So we know these emissions contribute to climate change, but how do they contribute to air pollution? So nitrous oxide, sulfur dioxide, carbon monoxide, and halocarbons linger in the air as particulate matter, which is also known as soot or smog. And these materials, these substances are toxic, cancer-causing compounds. And they are released by fossil fuel combustion and industrial processes. And prolonged exposure can lead to a variety of health effects, including, but not limited to, asthma, chronic headaches, reproductive issues, and birth defects, which disproportionately affect women of color, and even lung disease and lung cancer. So what are the health impacts of rising surface temperatures? Deaths from extreme weather anomalies over the last 5 years alone outnumbered death totals from the 80s, 90s, and 2000s respectively. Tropical cyclones, drought, and heat wave events and severe storms are amongst the most deadly. Furthermore, extreme heat events are increasingly common and worsening occurrences in our changing climate, creating the conditions for heat stroke to happen more frequently. Heat stroke occurs when the body reaches internal temperatures greater than 104 degrees. This week, Oregon saw temperatures of 115 degrees Fahrenheit. The climate crisis is now. And sustained exposure to high temperatures can result in damage to vital organs like the brain, heart, kidneys, and muscles. Furthermore, if a weather anomaly or climate change results in homelessness or emigration, displaced people are more likely to experience increased stress, vulnerability to violence, exposure to severe weather, chronic disease, malnutrition, mental illness, and risk of premature death. People suffering from homelessness and displacement also face obstacles to accessing healthcare. And just to circle back, the brunt of disasters fall most severely on low-income communities of color. Black residents are less likely to receive disaster aid and possess less than 15% of mean net wealth compared to white Americans who receive more aid on both the individual and community level. So what's next? Next, you will see my team go over the proposed solution to these issues, the science behind the solution, the issues and controversies that might arise, how we're going to measure the success of this act, and the final briefing. And that is all for today. Any questions?
I'm curious, how does this bill compare to the areas in terms of scope? Is it competitive?
So you're asking about how this initiative compares to other areas like the EU and scope and like leading areas. I will be completely honest, I haven't done much research into comparing to other initiatives, but I can circle back to that one. Dee? Yes.
So you support climate impacted communities, so color and how does the bill do anything to address communities being drought sensitive, hundreds if not thousands? Do you have an idea of who's going to get a priority investment and for which communities they are?
Okay, so the question was, how are we going to decide which climate impacted communities are going to be prioritized? Well, hopefully, remember that this act, the goal of it is not to be the main supporter, but to stimulate more investment into these communities. So even if it does not directly invest in each community, its goal is to stimulate investment in all these communities.
I saw that there's a plan to add more local and state briefings. Do you know the percentage of states that have local briefings now? What percentage does not?
So the question was, what is if we knew the percentage of states that already have local green banks? I do not have that number on me, but I do know that there are green banks that exist in certain areas, but there are also areas that do lack green banks. I do not know the exact states though.
Final question.
I guess kind of backing up from that, could you explain how green bank is different from regular bank?
Okay, yeah. So the question is how a green bank is different from a regular bank. So a green bank isn't like a regular bank and that's like, oh, like I'm putting my money in to save this and to like have a debit card. It's more of a source of income for loans. And these loans are specifically towards green projects such as clean energy and sustainability. So we call it a green bank by bank meaning it is the source of funds.
Very good. All right, thank you very much. So interestingly, a couple of questions that just came up are going to be answered in the fall semester when we do something called a program design. So over the summer, we're trying to understand the science of the problem, the nature of the problem, the science of the solution. In the fall, we're gonna actually have to figure out, so this $100 billion, where's it gonna go? And how do we figure out which communities get priority and which projects get priority? None of which we're gonna do until the fall. So those are critical questions. And the question about where are the current green banks? That's gonna have to be part of the answer. You're gonna need to, you don't necessarily wanna, well, actually this would be a choice. Do we focus on the places where we already got things going to really get them moving? Or do we focus on places where nothing's happened? And fortunately, I don't have to decide that. That's part of what the group has to decide in the fall semester. But these are really good examples of what we're going to be doing in the fall semester. So with that, let's take a couple minute break and then we'll do third brief.
Can you say touch bases or touch base?
Touch base.
Okay, why don't we find our seats and we'll begin again. Okay, our third briefing is also focusing on plastics, the Break Free from Plastic Act, being advised by Professor and Elsie is here. Please come forward and
Is everyone able to hear me okay? Good morning. My name is Elise Bird, and I'm here to present on the Break Free from Plastics Act of 2021. Before I get started, I want to take a minute to thank my team, with a special thanks to Amy Cowitz, Max Galazi, and Aiden Kings Nancy. I'd also like to thank our advisor, Dr. Cook. So why are we talking about plastics? There's several problems with the plastic life cycle. Everything from production and consumption all the way to waste management, as you can see here. This is a picture from the Philippines, which is actually one of the countries that the United States exports our plastic waste to. To understand the full scope of the plastics problem, we have to go back to the 1940s when fracking was invented. Fracking is the process of injecting hydraulic fluid into the Earth's core to extract the oil and gas out there. As a result of this innovation, we had a supply glut. At the same time, analysts were predicting that the demand for fuel was going to go down. This led petrochemical companies to make a push into the plastics market. And we can see that in the remnants of the mass production and consumption that we have today. Plastics is particularly advantageous from a manufacturing perspective because it's both durable and cheap to produce. Looking to the future, we expect the demand for plastics to double by 2030. This is problematic because petrochemical companies are using this as a justification to continue the exploration and extraction of oil. Additionally, it's a problem because the largest market for plastics is in single-use plastics, which creates an issue on the waste management side of things. As we move through the rest of this presentation, we're going to talk about how some greenhouse gases are emitted and how plastic leads to a pollution problem. So looking at the plastics life cycle, you can see that it begins with extraction and then it moves through the refinement and cracking stages, which creates the products to make raw plastic, which are called nurdles. So nurdles are little pellets of plastics that can be used to make the final product. The final product is then distributed all around the world using ocean, air, and land transportation. It's then consumed and it becomes waste. Once it enters the waste management system, we see that it can become three types of waste. It's either recycled, it's reused, or it ends up in a landfill as waste. So I'd like to highlight a few things on this slide. Most importantly, this is a fracking device in the middle, the giant red tower. And it creates fractures in the Earth's core where the oil is, and that's how it extracts all the oil and gas from the ground. As a result of the fracking and the fractures that it's creating and injecting the hydraulic fluid in, you can see how that it would easily seep into the neighboring communities' water supplies all the way on the left side. So for the next few slides, I'm going to focus on some of the health and environmental concerns of the production of plastics. So when we think about the environmental consequences of plastic, it really starts with the extraction process. So during extraction, methane is released both accidentally and intentionally. Methane is particularly problematic from a greenhouse gas perspective because it's 80 times more potent than carbon dioxide. Other emissions and toxic spills are also happen all throughout the plastics production life cycle. Everything from extraction and manufacturing to the distribution of minerals. We see that this causes air, land, and ocean pollution. This is an example of the aftermath of nurdle spills. So nurdles are those raw plastic pellets that I mentioned earlier, and as you can see, they're really tiny and they look like fish food. So oftentimes fish can consume nurdles thinking that they're food, and they end up malnourished because their bodies aren't able to digest them. When we turn to the public health effects of plastic production, we see that chemical facilities are releasing hazardous air pollutants into the air. HAPs are tracked by the federal government because there are no carcinogens. A recent study suggested that COVID mortality rates were correlated with higher exposure to HAPs. Another hazardous health effect of the production of plastic is the use of BPAs and phthalates in production of plastic. BPAs and phthalates make plastics more durable, so they're advantageous from a production perspective. However, they're detrimental to our health. Recent legislation went into effect to ban using BPA and phthalates because of their toxic effect on people. Other toxic chemicals are released into the air that are linked to cancer and asthma all throughout the production process. As we look at the second half of the production life cycle, or excuse me, the plastic life cycle, we can see that we're only going to focus on waste today. In future presentations, we'll talk a little bit more about the recycling and reuse side of things. So there are several environmental consequences of waste. This largely stems from the fact that only 91% of plastic is recycled. Or is, excuse me, I'm sorry, 91% of plastic is not recycled, so only 9% of plastic is recycled, which means that 91% of plastic is ending up in landfills and the ocean. So landfill plastics are particularly problematic because 80% of landfills have leaks, which means that those chemicals are then being leaked out through the ground to local water and soil supplies. So plastics, as they decompose, also emit greenhouse gases and other toxins into the atmosphere. Ocean pollution has another side of the plastic waste management process. The ocean pollution is linked to a decrease in biodiversity and an increase in spread of disease among marine life. Ocean plastic is also consumed by marine animals. So I mentioned earlier how fish would eat nurdles, but they also consume microplastics, which are fragments of plastic smaller than 5 millimeters that result from the breakdown of plastic. Microplastics end up bioaccumulating in the food chain, which means smaller fish are eating microplastics, then bigger fish are eating those fish, and then humans are consuming those fish, which means that humans end up, excuse me, I'm sorry. So the bioaccumulation of microplastics is leading to health concerns in the human population. We see that microplastics act as endocrine disruptors in the body. So endocrine disruptors affect our body's ability to produce natural hormones that are vital to life. Microplastics are also associated with inflammation and DNA damage. The full toxic effects of microplastics are not fully understood, and research is currently being done to fully understand how this will impact all of human health. BPAs and phthalates, as I mentioned earlier, were recently banned. These are both types of microplastics. We've talked a lot about the public health effects of plastic production and waste. Now we'd like to focus a little bit more on who is actually impacted by this process. The socioeconomically disadvantaged communities are more likely to be impacted by the plastic production and waste management problem. We see that oil fields are located on tribal lands, which means as we're emitting toxins into the air and the land, their communities are most likely to be impacted. Fence-line communities are located near petrochemical and other chemical facilities. People of color are twice as likely to live within petrochemical fence-line communities and twice as likely to be exposed to the harmful chemicals that they're producing. We also see that there's a disproportionately higher risk to toxic chemicals in the air. Higher rates of cancer and asthma are seen, and as we look to Louisiana's Cancer Alley, we can see an example of how a community that's surrounded by over 200 petrochemical facilities see much higher rates of cancer and asthma. Another example of how the plastic problem disproportionately impacts socioeconomically disadvantaged communities is that waste dumps and incineration sites are located in low-income communities of color. When we look to the solution to this problem, this bill is going to address three core issues of the plastic problem. The first is plastic waste overproduction and consumption. We'll address this by extending producer responsibility and banning single-use plastics and papers. We will also be reducing other sources of plastic in the environment. Another way that this bill is going to address the plastic problem is by standardizing recycling and composting practices. The last way that this bill is going to address the plastic problem is through technology and research. So we will be increasing local government efforts using social media to target exactly where waste production is. As a result, we'll be able to actually get involved in the communities and start grassroots movements as opposed to just coming in as big government. The last way that we will address the core plastic problem is through funding for innovative projects. We're going to focus on answering questions like, can we take microplastics out of the ocean? And is it possible to make plastics that don't decompose into microplastics? Every week, we consume 1 credit card's worth of plastic. Throughout this presentation, we discussed many of the health concerns associated with microplastics and the plastic life cycle altogether. I hope you agree that this is pressing legislation that we need to get passed. In the next few weeks, we'll be discussing more of the solutions that we're proposing in this bill. Thank you very much for your time. Are there any questions at this time?
Good, very good.
I'm curious about when you mentioned, first of all, breakdown. Excellent. When you mentioned that the breakdown of plastics in emits gases in and of itself. Is that through the incineration of plastic that you're destroying them, or is it the actual breakdown and cycle of plastic that emits that?
So the question was whether, as plastics decompose, they also emit greenhouse gases, or it's through incineration. So it's actually through both, because plastics are a byproduct of fossil fuels. There are some like petrochemicals that are emitted when they kind of decompose. I didn't mention it, but plastics take anywhere from like 50 to 600 years to decompose. So it's like a really slow process of that coming through, but in aggregate, that's a pretty big impact.
Does microplastic pollution have a disproportionate impact on our communities, due to access to healthier food, or is that pretty, not that we can see it in the but that's pretty much the same for us?
So it's a global average. Oh, I'm sorry. So the question was whether the microplastic consumption is seen disproportionately in socioeconomically disadvantaged communities, or if that's across. My understanding is that statistic is a global average, so that's looking at communities that are more likely to consume fish, averaged also with communities that are less likely to consume fish. Like obviously island nations and stuff like that eat a lot more fish, and kind of the way that microplastics are spread, we see them all the way in the Arctic and the polar, so it kind of impacts everyone. Yeah.
What are the consequences of microplastic leaking into soils?
Yeah, so, oh, yeah, I keep doing that. So Kayla's question was speaking more to the way that microplastics are leaking into the soils. So when there's leaks in soils and it rains, and there's a bunch of plastic sitting there, the plastic just sits in the water, effectively like plastics in oceans. And then those leaks in the liners leads to it like just falling into the local soil and continuing to contaminate that. So we see that areas where there's like more rain, that's more likely to happen.
Thank you, Shirley.
Wow. We're just kind of rolling through.
Yeah, yeah, so I'm usually in early.
Looks like we're ready.
Yes.
So our next briefing is on the Climate Stewardship Act, and Morgan is going to brief us on it. And this is a team advised by Professor Palmer, sitting right here. Okay.
All right, can everyone hear me okay? Perfect. So good morning, everyone. As Dr. Cohen said, my name is Morgan Brewer, and I will be presenting the midterm briefing on behalf of the Climate Stewardship Act Workshop team. Before we get started, I'd like to thank my output team, Nikki, Megan, and Karen, as well as the rest of our workshop team and our faculty advisor, Professor Palmer. So when you think of climate change solution, you often think of new technology or green energy, but today we would like to illustrate to you how these three systems on the screen today, our U.S. agricultural lands, forests, and wetlands can also be a part of that solution. The Climate Stewardship Act aims to improve land management practices for these three ecosystems in order to increase their ability to sequester carbon, thus curbing the effects of climate change. So we'll start today by running through each of these three systems and showing how climate change is impacting them through a case study for each one. And we will also show how these three systems are contributing to climate change. And then finally, we will show how the Climate Stewardship Act aims to address these problems. And we'll begin with agriculture. For our case study, we'll be examining California, which grows about 13% of the US's total agricultural foods, as well as 2/3 of our nation's fruit and nuts. In 2015, California experienced a sustained drought that resulted in the loss of 540,000 acres of agricultural lands, $900 million in revenue, and 10,000 jobs. Farmers were also forced to tap into depleting groundwater reserves because of the lack of precipitation, thus further depleting the aquifers supply for later generations. And this drought disproportionately affected Latinx communities and other migratory and seasonal workers who rely on the agricultural industry for employment. So agriculture can be affected by climate change in several different ways, but today we'll focus on the Southwest and the case of drought. So decreases in precipitation have led to droughts in the Southwest, and increases in temperature have led to the decrease in snowpack and depleting aquifers, leaving less available water for farmers to irrigate their lands. And here you can see that same 2015 drought that I talked about before, where yellow indicates abnormally dry regions, and the red indicates exceptional drought conditions. And here we can see what that looks like today in 2021. Already this June, the Southwest has experienced the worst drought conditions in the past 20 years. Agriculture is also affecting climate change. In 2019, 10% of US greenhouse gases came from agricultural practices. These gases include things like carbon dioxide, methane, and nitrous oxide. And specific industrial practices that we use are the ones contributing to these emissions. And these include things like overuse of fertilizers, monocropping, which is the growth of the same crop year over year on the same land, thus depleting the soil health, poor management of manure, and overuse of tilling. These practices are all degrading the health of the soil and also depleting and increasing the risk of crop loss. And so these effects on California are not only affecting California and the Southwest, but the entire US agricultural food system. Next, we will discuss forestry. For our case study, we will be examining Oregon, which, as you heard earlier today, is experiencing record high temperatures this week. And in 2020, Oregon had one of the worst fire seasons that the state has seen in many years, which resulted in 1.2 million acres of burned area, 5,000 homes destroyed, and $1.15 billion for wildfire damages, response costs, and debris removal. And the communities affected by these wildfires are at increased risk for poverty and housing instability. Climate change effects are changing, and changing weather patterns are bringing drier climates, which are increasing the risk of drought and thus increasing the risk of wildfires in these areas. And changing climate patterns also shift the range of pests and diseases. For in the case of the Pacific Northwest, the pine beetle has recently moved into the area when it previously lived in a more southern latitude. As you can see in this photo, it is decimating trees in the forest permanently ending their ability to sequester carbon and leaving them at risk as fodder for wildfires. Forests are also affecting climate change. Well, normally, they act as carbon sinks and they store carbon dioxide in their biomass and their soils. However, and they currently sequester about 14% of US carbon dioxide emissions. However, with these greater wildfires, they're emitting more CO2 into the air. And once the fires have torn through these forests, it limits the lifetime potential of trees, limits their ability to sequester carbon, and thus leaves carbon from other emissions, say like factories or transport, leaves that into the atmosphere because there's nothing to absorb it. And fires are increasing in the US. Burned area due to wildfires there's been a dramatic spike, as you can see here. The red line indicates 1984 to 2000, and the blue line indicates 2001 to 2017. Finally, we will talk about the coastal wetlands. Our case study will examine the Mississippi River Delta, one of the largest wetland systems in the United States and a great area for biodiversity that has been unfortunately degraded by anthropogenic and climate change effects. Every 90 minutes, every 1 hour and a half, we lose an entire football field of land from this delta. And since 1930, that has equated to about 5,000 square kilometers lost, which equals the size of the state of Delaware. This leaves the land more vulnerable to more frequent flooding and disproportionately affects low-income and minority communities. In the case of the Mississippi River Delta, this is often Black communities that disproportionately live in more vulnerable coastal regions. Erosion due to rising sea levels and increased salinity of the wetlands due to encroaching ocean water is leading to the loss of necessary sedimentation, vegetation, biodiversity, and increased vulnerability to flooding in these areas. Here you can see illustrated that 5,000 square kilometers that we've lost in the Mississippi River Delta. But keep in mind that this is from the year 2000. It's been 21 years since then. And so the wetland system has degraded even more. Finally, the wetlands are also affecting climate change. In a normal condition, microorganisms that live in the soil perform anaerobic respiration, thus releasing carbon dioxide very slowly, allowing wetlands to act as a carbon sink. However, when those rising sea levels pull that soil and vegetation out into the open ocean, these microorganisms start to perform aerobic respiration due to increased oxygen levels in the ocean, thus causing a 66% increase in the rate of CO2 release than before. And this erosion also decreases the size of the carbon sink, allowing more carbon to stay in the atmosphere. Now that we've discussed some of the problems associated with these systems, we can talk a little more about how the Climate Stewardship Act aims to take these systems and improve our land management practices in order to allow them to perform their ability to sequester carbon and curb the effects of climate change. The main goal of the act is to enhance the health of US agricultural systems, forests, and coastal wetlands and estuaries, and it does this through three main methods. The first is investment in existing programs with specific allotment for underserved and minority communities. The second is expansion of land management practices, programs that are currently existing. And the final is to prioritize climate stewardship in all three of these systems. The first title deals with agriculture and is mainly concerned with improving climate stewardship practices like composting and biochar application and it will also expand these three programs that you can see here. All three of these programs will receive an increase of funding of $44 million with 5% allotted to minority and communities of color. The second title deals with forestry and is primarily concerned with reforestation with an emphasis on habitat connectivity, wildfire prevention, and carbon sequestration. It introduces a few new programs, one of which, notably the Stewardship Corps, will create hundreds of thousands of new green jobs for minority communities through tree planting and tree nurseries. Finally, the last title deals with the coastal wetlands, and it is primarily concerned with management of these wetland systems through technical assistance, data monitoring, and research. And the Coastal Estuary and Resilience Grant Program aims to restore 1.5 million acres of wetlands by 2030. And this will also bring employment opportunities for people living in these vulnerable coastal communities. Climate Stewardship Act aims to help turn the tide of climate change through agricultural, forest and wetland systems. And throughout the course of the semester, we will talk more about how we plan to go about these solutions. But for now, thank you very much for listening, and I can take any questions.
In the agricultural section, you mentioned monocropping. And I was just wondering if in your research, you got any consensus on if farmers understand the impacts of monocropping, right? And the general consensus on, are they willing to change? When you present it to us, it's very obvious, right? But if you go and talk to these guys, do they understand?
So for everyone on Zoom, Blake was asking if farmers understand the effects of monocropping and if they would be willing to switch their practices. And in our research, I don't know if that has come up specifically. However, I do know that the way that the grant programs work for this bill, farmers that are aware of it would be able to apply to try and rework their lands and redo how they grow things. That makes sense, but we haven't looked into specifically if this is a problem that general farmers are aware of.
When a tree burns, does it release more carbon than it sequesters in its life, or is it more or less?
To my knowledge, Max was asking if when a tree burns, if it's releasing more carbon than it sequesters. And to my knowledge, no, it releases just the carbon that it has been sequestering, as well as, but more carbon ends up released in the wildfires due to, burnt shrubbery and other things like that. But for the one, if we say, use the example of one tree specifically, it's just the carbon contained. Interesting.
I was just wondering, that's the agriculture sector. Does it go with that irrigation that groundwater depletion is going to be prominent in the farm techniques like irrigation? Is that something that
For the people on Zoom, Trish asked if that the bill addresses groundwater irrigation techniques, and to my knowledge, I'm not sure, but I can get back to you on that one.
I was curious about this. Do they normally undergo anaerobic processes just because oxygen is not as abundant in a wetland environment? Or is it also because since more ocean water invasive species that are anaerobic and also are climate
So Caleb asked about the microorganisms living in wetlands and whether or not being pulled into the ocean is like how they begin performing aerobic respiration if it's due to outside factors or just the fact that they've been moved out of their environment. Is that
why do they do this?
Yeah. So waters in wetland systems are very still typically. So there's not a lot of oxygen coming in. And so they usually they perform anaerobic respiration just because there's not a lot of excess oxygen in still water. But when the soil is like broken apart and taken out into the ocean, there's greater oxygen levels in the ocean. So just because of the increase in oxygen levels there in that environment, they're able to perform aerobic respiration, if that makes sense.
what about non-coastal and what?
I am not positive. I know that there is a large emphasis on coastal wetlands. However, there is some parts of the bill do discuss how we could take land that was previously turned into, say, agricultural lands in the Midwest, and if a farmer wants to apply for a grant to restore that land, I do believe that's included to restore it to its closer to its original.
Thank you very much. Wonderful. Okay, very sophisticated science questions here.
I love it.
Don't get used to it. Wonderful questions. Great response. Great briefing. Let's take another 3-minute briefing, and then we'll have our final midterm briefing.
Serving Marines.
I figured. Okay.
I was in for 5 years. Back in kind of changes you. It was like, yes. I fortunately didn't get sent to any like actual war zones. Like the most dangerous place I was sent to was well, very different mission. It's become more. No, but it doesn't prevent us from increasing our everything is a proportional response. When I was there, people are out of order. I don't think the future of the board is going to be it's just sad. I have this really special chapter. I just
Oh, no. I knew she would never get it. It'd be great.
Okay, can I ask everybody to find their seats? We'll begin.
I knew she would never get it. No, I know that, but you guys were really hard.
Please, everybody, find a seat and let's give our undivided attention to our briefer. And we're going to hear about the Environmental Justice Mapping and Data Collection Act with Professor Rosa advising. And if everybody is ready, we'll begin.
Hello, my name is Matthew Horn. I'll be presenting on HR 516, the Environmental Justice Mapping and Data Collection Act of 2021. I wanted to start by thanking my output team, Mike Becker and Dennis Coleman, for all of their help, as well as the rest of my workshop crew for their support, and our brilliant advisor, Professor Rosen. For this presentation, I'll begin with an introduction to the bill, followed by an overview of the problem and the science behind the problem. We'll dive into a few case studies, and then I'll discuss the future directions for this issue and summarize the impacts of the bill. The Environmental Justice Mapping and Data Collection Act of 2021 was introduced by Congresswoman Cori Bush this January and begins by defining an environmental justice community as a community with significant representation of communities of color, low-income communities, or tribal and indigenous communities that experiences or is at risk of experiencing higher or more adverse human health or environmental effects as compared to other communities. With this working definition, the bill will establish a committee led by the Environmental Protection Agency, which will gather and maintain data relating to socioeconomic factors, pollution and public health, to create a nationwide map, which will be able to connect communities to relevant investments. To provide some background on the environmental justice movement, this is not a recent issue, and these communities have often been fighting for their rights for hundreds, if not thousands of years. But the modern environmental justice movement that has led to this bill mostly started to rise in the 1960s when we see small-scale protests to large waste management projects. As a result, by the 1980s, we had seen established not in my backyard policies where wealthier and wider communities had enacted policy prohibiting the placement of toxic waste sites and land management sites in their immediate vicinity, which resulted in Black community leaders organizing and beginning to protest and seeing this movement on a national scale. And then in 1987, the Racial Justice Report concluded that the positioning of hazardous facilities in communities of color was not coincidental, but the result of these local and federal policies. It wasn't until 1994 that President Clinton signed Executive Order 12898, which was the first federal action towards environmental justice that required federal agencies make environmental justice part of their mission. Seeing as that was relatively broad, in the decades since, environmental groups are still underfunded and still lacking the political power necessary to change the systems that have resulted in these environmental justices and may continue to result in these environmental justices. For example, zip code is still the greatest predictor of long-term health. Race is still one of the most powerful predictors of access to healthy food, which is only exacerbated by the recent pandemic. And kids in Flint, Michigan still have lead in their water, which we'll talk about in a few minutes. The major environmental hazards that the bill is going to be looking at include air pollution, water pollution, soil pollution, and climate change. So we're going to be talking about those in a little bit more detail. For air pollution, we're going to focus on particulate matter as it has extreme effects on human health, which are fine particles smaller than 2.5 micrometers that are suspended in the air from emissions, dust, smoke, which can lead to aggravated lung disease, asthma, and inflammation. And from an environmental justice perspective, Black Americans are exposed to 21% more particulate matter pollution than white Americans. For water pollution, you find heavy metals, chemicals, fertilizer, oil, and more in water as a result of sewage, agricultural production, oil spills, and leakage. These chemicals can result in cell decay, diarrhea, decreased muscle and bone growth, with tens of thousands of individuals dying every day around the world due to complications originating from water pollution. And a violation of water systems regulations are 40% more likely to occur in the US in communities with majority of people of color. For soil pollution, we find a lot of those same chemicals that are in water pollution, but resulting from improper or failed management of toxic waste, which can lead to cancers, leukemia, and nervous system damage. And we find that the majority of people living less than 2 miles away from toxic waste facilities are people of color. Lastly, the effects of climate change including increased frequency and intensity of extreme weather events caused by industrial emissions, deforestation, permafrost thawing. Particularly impacts we see are sea level rise for marginalized communities, as well as property damage and migration. This photo illustrates the Ecological Indian Nation in Washington State, which has had to move from their ancestral home due to rising sea levels. Now that we've established some of the science behind the issue, I want to cement the connection between socioeconomic class and environmental effects with two case studies. Beginning with Katrina. Katrina was a massive hurricane that hit the southeastern United States in 2005, resulting in billions of dollars of property damage and serious flooding in New Orleans. Looking at these two maps here, on the left, we see the racial demographics in New Orleans, where the greener dots represent Black communities and the orange dots represent white communities, each dot representing 5 people. And then in that same area on the right, we see increased levels of flooding with the warmer, darker colors representing higher levels of flooding, with the cooler, lighter colors representing low levels of flooding. As we can see, the areas most strongly impacted were those that were predominantly Black communities, given that they didn't have the resources available before the hurricane to upgrade their levee infrastructure, resulting in much worse flooding in these areas. And even following the hurricane, that same issue of lack of resources has contributed to these communities having a much more difficult time rebuilding and reestablishing their communities in the wake of the hurricane. Even 15 years have passed, these communities haven't fully recovered in comparison to the bounce back we've seen from the white communities in New Orleans. Next, I want to talk a little bit about Flint, Michigan, where in 2014, the city changed their water supply in efforts to save money. But the difference in water composition resulted in significant lead leaching. We had complaints around water color, odor, with a lot of people reporting rashes due to the water. And as we can see here, Flint is a predominantly low-income community. The map on the left indicating median household income, with the majority of the community having median household incomes of below 40,000. As you can see, the lighter colors represent lower incomes, the darker colors representing higher incomes. And then on the right, the darker red areas indicate the communities that were most impacted by the leaching. And we can see that the lower income members of the community, even in this region, were more strongly impacted than the wealthier communities, just because Flint didn't have access to a lot of political and economic resources before the switch. So their water systems had been outdated. And even now, trying to improve those systems has proved especially difficult for these communities. Discussing the kind of the specifics about lead levels, in Flint, kids were, before the water switch, children already had, there was 2.5% of children had elevated levels of lead in their blood. And after the switch, nearly 5% of children had elevated levels of lead in their blood, with only 1% of children in the surrounding areas exhibiting high levels of lead, both before and after the switch, illustrating the failed system that contributed to these children being exposed to higher amounts of lead. I just wanted to wrap up by again indicating how important this map is to these communities, because it will not only identify them at a national scale, which we currently don't have any national method of doing so, and then bring them to the decision table so they can create equitable development for the future. Thank you, and I'll take any questions.
one and the next one. You referenced some DEI aspects of this legislation. As I understand it, there are plenty of indigenous folk who live on and use the land. So I'm just wondering, how would the act impact them? What would
So Seth's question was, how will this impact, affect tribal and indigenous communities specifically? Is that correct? So as we can see from the example, a lot of tribal and indigenous communities are most strongly impacted by climate change, given the areas they're in. And with this bill, the map will help identify them on a national scale, which will enable them to apply for funding, which we can see is already being set aside in the majority of bills that are being introduced, as the ones we talked about today, which already have 40% allocated towards these communities. So being able to be identified by this bill as targeted communities makes them more eligible for that relevant investment.
Could you explain the water source switch a little more in Flint?
Yes, so in Flint, they changed their water source to a local river in an attempt to save money than bringing water from further away as they were currently doing. The changing in water composition though from the river to their original source led that water to contribute to significant amount of lead leaching in the pipes, which then increased the amount of lead exposure that children and individuals were facing in the Flint community.
So does this plan, plan to have a user-friendly interface on the website or something like that, that is accessible to public access?
Yeah, so the question was, does this bill create an interface that is accessible to communities so they can utilize this data? And yes, the bill is tasked with establishing a data repository that is accessible to local, regional, federal, and indigenous communities so that they can visualize and use this data to apply for relevant federal investments. They did have some concerns about how aggregated data is because they don't want individuals to be identified, but still using that data, they should be able to identify themselves as environmental justice communities in terms of accessing then relevant federal funds.
Are you redefining the definition of impact? What are the boundaries of the impact we can do? Or are you already following?
Right, so this bill is especially important in that right now, despite a lot of environmental justice language and a lot of policies around the US, there's no current nationwide standard for what that means for a community, and it makes it harder for these communities to access resources even when they're set aside specifically for them. And so by providing a workable definition and identifying these communities in a national scope, it'll help these communities to then access these resources available to them. So in providing the definition, it's primarily just to create a threshold that can be used across the country.
Yeah, I was curious about, you mentioned soil pollution as one of the causes of cancer like leukemia. I was wondering how the soil pollution actually affected communities through direct exposure.
Yeah, so Matt's question was how soil pollutants interact with the community in order to expose them to these pollutants. I'm not sure all of the effects, but one of the ones that we found in our research is that as these pollutants enter the soil, nearby communities, they are brought up a lot in dust from wind erosion. And so, especially if individuals are outside, they are more likely interact with these contaminants. question was, given that a lot of this data is already readily available and being used by the EPA and contributed by the Census Bureau, why is this not necessary? And that is a great question because the EPA does already have some GIS examples of maps that you can use to layer these specific variables. But this bill is necessary in providing that working definition across the country and providing a multi-bureau committee, which then contributes to this map on a variety of different levels, making these funds more accessible to these communities because they're already connected to the relevant bureaus, whether that's energy, health and human services, commerce, that they might be trying to seek funds for. They're already included in the committee and therefore will be easier to address and access.
Thank you very much. So, what did we learn here? First we learned that each group really did a spectacular job. And so let's give ourselves a round of applause for terrific. There's a bunch of process issues I want you to be thinking about, because right now we're talking about environmental justice, we're talking about forests, we're talking about different environmental issues. And you'll find through your career, you'll be approaching lots of different issues. So what's our takeaway? What are the professional skills we're trying to get here? Well, the first thing is, look at the level of sophistication that you've reached in your areas in 30 days by working together and learning about these statutes and what the thinking that underlies them. And we're only at the very beginning of understanding the environmental problem. But that kind of in-depth collective treatment, you're talking to a dozen people fairly frequently about the same issue. And that learning process is extremely important. Sharing information, building an understanding, asking questions. You know, I mean, the question we just heard, well, the Census Bureau does this and so forth. Well, why doesn't it exist? But then the answer is having a standard definition that they can then be used in other programs is absolutely essential. The degree to which government does things to define something should never be underestimated. The best example of this is, what is an unemployed person? If you look at unemployment data, which by the way, the definition of which has changed over the last 60, 70 years on a fairly regular basis, if you're not looking for a job, you're not unemployed, according to this. So if I give up, I'm not counted at all. That's the measure. Everybody agrees that's the measure, but it's not measuring everything that we might want to measure. Okay, so the point here is to think about what is it we're learning collectively and what's the process. Remember, we threw you into these groups based on your choice. We selected people to be in charge. And within a week, they consulted with you and produced a work plan, which we've been following, which is why we get to the point where we have fairly sophisticated presentations of problems that we hadn't really thought much about before a month ago. I would hold these presentations up against anything you could see by experts in the field. Because what you also did is you condensed it into 10 minutes. I mean, you could have talked for an hour on each of these subjects easily. And the hard part is actually getting it down to the 10 minutes and thinking about what's the most important thing for me to communicate. And then practicing that communication and honing it so that people can understand. In other words, other people in the room here have not been spending the whole semester on your problem, but you have to convey to them enough that they could actually engage in a conversation with you and understand what you're trying to say. This is an absolutely critical skill as a professional in a technologically complex world that will be constantly changing. The degree to which today's problems are going to be different from the problems you're going to study and work on in 20 years should never be underestimated. You're going to be focusing on ever more complicated problems. And so these basic skills of working together, communication, and learning is extremely important. The other thing that I'd say about everybody here is you're at a point in your career where you're open to learn. You've come to school, you want to learn, that's why you're here. You're devoted to it. In our field, you can't ever stop doing this. You're going to have to be learning through your whole career. The nature of problems that I studied and worked on when I started in this field in 1975, radically different in 2021. And I have to keep it, and I sit here listening to you because I pick up stuff every time there's a briefing here of things that I hadn't thought about and didn't know. And I know an awful lot about environmental policy, but I will always learn. And so I want to conclude by urging you to keep this spirit of inquiry through your career. Don't ever get to the point where you say, oh, I know that, I'm the expert. Okay, because that's never going to happen in this field. All of the things that we study are intersected and interacting with each other and continue to change. So you think about the issue of plastics or toxics, climate change. And so I want to congratulate everybody for really doing a great job. I found the briefings thrilling, actually. And I know I speak for the faculty and say this is excellent job. And I'm really looking forward to the final. So congratulations and thank you.